My name's Andreas, and I work as a chief architect as part of the APAC CTO office, and I'm based in Sydney, Australia. In today's session, I'll be covering AI adoption patterns for cross-industry use cases. Again, Ahilan Pondusamy and myself, we have written an O'Reilly book on this topic. It's just a small read, but it's a good compilation of what we have encountered over the last 1 to 2 years in terms of AI use cases and how to best address them across different industries. So today's agenda is a quick recap on Gen AI versus predictive AI, the challenges and risks associated that the industry is currently addressing, and then patterns identified and specific use cases across industries. So generative AI has basically revolutionized the focus back on the artificial intelligence topic in general, which ChatGPT, a big new hype and amazement has come out really about what artificial intelligence can do. The transformer and attention-based architectures have basically lifted the possibilities of what use cases artificial intelligence can be applied to, whereas predictive AI has been in production for many years for fraud detection, for complex scenarios, for quality control, or for visual inspection, for example. And the challenges and risks at a high level, as we know, there is model bias, there is the open source availability of data that has been used to train those models. There's also a sustainability type challenge in terms of how much power has been consumed to train models and also to run in inference. And then there is also the data volume and the data privacy type concerns, just to name a few. And in terms of pattern now, there are high-level pattern categories that I brought to you today. So one is the AI adoption patterns. This is really around how is AI adopted in an organization. Are you forming small centralized teams like a COE, for example, that collaborates across the different business units, or are there specific smaller teams inside a business unit that play around with artificial intelligence and just learn the power and the use cases that an AI or artificial intelligence, machine learning use case can be applied to? Or is there a data-centric approach where organizations with strong data quality practices extend the team's accountability to also move into AI ML use cases for the business? Or is there, lastly but not leastly, a pure business value type approach where teams and organizations just focus on the biggest return on investment, whether it's risk reduction or cost reduction or revenue generation, that actually a AI and ML system or solution can be applied to? Then from a pattern category perspective, we have a data pattern. I already alluded a little bit to that. It's data and model training could be one category, because this is all about how do I best prepare and get access to the right amount of data at the right time to actually train my models and make those models provide the best value to the business. There are things like a model-centric approach, a data-centric approach, and a system-centric approach that both determine the strategy on how you drive here. Then as a next step, we have a model pattern category, which could also be called model or inference type patterns. This is about how do you deploy those models for inference. Is it centralized? Is it a federated approach? Is it a distributed approach? Is it a A/B testing type approach? Is it a blue-green deployment type approach to really test out the best performance for your models? And then we have as a next step the operationalisation patterns. This is all about how do I streamline the entire process, often called MLOps, like machine learning operations, from model training and data preparation all the way to model monitoring and observability in terms of model drift and model performance at the edge or centrally. And then we have at the very bottom here infrastructure provisioning patterns. They are all about how do I either on demand or statically provision the infrastructure that I need? How do I cater for seasonal bursts, for example, or for just consumer patterns as such? How do I secure my infrastructure from core to the edge? And how do I automate that and secure the AI and ML infrastructure as such? So those are the pattern categories that are applied across cross-industry use cases. And now let's look at those use cases. Those could be in healthcare, for example, if different hospitals work together in a federated learning type scenario for disease prevention and research on how to identify specific health risks or health symptoms better and to classify them. In an aviation context, in the transport industry, we're looking at cabin waste prediction to reduce the carbon footprint, not just for the flight and the fuel used to carry that waste from A to B, but also to predict what kind of food and equipment is used, like headphones on a flight, for example. Then in a FSI related context of financial services industry would be like fraud detections for transactions or cross-border transactions. In the manufacturing and industrial automation space, we actually just developed a multimodal and multi-model use case with one of our partners. The way it works, we're utilizing OpenShift as a AI platform that provides the MLOps logic and capabilities, and then we have multiple models running on it. In that case, it was 3 models. We had a object detection model, and the mode would be basically image. It came from an RTSP stream from a camera that feeds into this object detection model. Then the second stage was an image to text model where that image basically got fed into another model, and that would then describe what's visible in terms of a compliance and safety compliance score. In that case, the use case was to measure safety compliance in terms of hard hat, safety vest, and face mask. And then lastly, we had deployed a RAG system like retrieval augmented generation with an LLM that you could then query in real time on what the current compliance rate is or compliance status is in that situation on a manufacturing floor, for example. This all got enabled through OpenShift AI, which is Red Hat's leading platform for deployment of AI use cases at scale. Earlier, I presented you with different categories of patterns. I called them out as adoption pattern, data pattern, and model training pattern, model and model serving pattern, ops patterns, and infrastructure provisioning pattern. So now I want to go a little bit deeper into those patterns so that you get an idea of what the conversations around those patterns and the different aspects of AI ML systems at scale in production actually mean. So first of all, adoption is around how organizations adopt AI and machine learning systems and solutions. So there are different approaches you can take. There's an iterative approach where specific business units just learn bit by bit around the new technology and what it can actually provide to the business. Then there's also a more formalized approach, which is a COE approach, a center of excellence approach, where either specific parts of an organization or all parts of an organization come to a centralized team that puts together a team of experts really that develop specific use cases for specific business units together. Then there's a data-centric approach for organizations that have already a strong data architecture and a strong data quality focus to basically expand the responsibilities of that team into the AI ML space. And then there's a purely value-driven approach where organizations basically say, what is the biggest value I can get out of an AI ML approach for my business? That could be risk reduction, cost reduction, or revenue generation as such. Once organizations have determined how to best adopt AI ML into their business, then we can go a little bit deeper and see what is the best data architecture and model training approach. So the data architectures have also developed over the last few years. So we have originally a fragmented and a bespoke approach where different systems had their own little database, and you would query those databases and write to it. Then, as a next step, a centralized approach has emerged where data lakes and data lakehouses have been deployed to have a central repository of the trusted data as such. And organizations then use that to train their AI/ML systems. Then there's a federated and a service-oriented approach. This is where kind of data mesh approach comes into play. The data mesh approach says fundamentally that you leave your data where it is. There is no ETL or ELT processes in place. You just query the data where it is, and you apply all sorts of pattern, whether it's caching, for example, or computational governance around that data mesh architecture, and you establish data as a product. Or realistically, organizations nowadays have a mix of all of the above. The reason this is important is because it fundamentally affects the quality and the deployment and the approach to your AI ML. So then from a model training perspective, you also need to think about feedback loops. Are you using supervised or unsupervised training? Do you have human feedback loops in your model training process? Do you use deep learning or federated learning, where you have the same model being trained in different locations and you just fuse those updated weights and parameters together again? Then moving on into the model and operational side of the things, if you then see model serving patterns and ops patterns, then you have either a single model in a centralized deployment, you have a multi-model deployment in a distributed fashion. As such, you have maybe then shadow, canary, or blue-green type deployments, or as I said earlier, federated model deployments in the context of a federated learning approach, where you have distributed locations all serving the same model, but also training the same model. That's why it's called federated learning. Then moving to the infrastructure bit again is the platform patterns that you have. That's usually driven by scalability requirements, whether you have stateful or stateless workloads associated with your AI system, what your resource demand is, whether it's a constant resource demand or a dynamic resource demand, or whether you have multi modality in your systems where you have different models, for example, text, images, video streams to be processed. So that all comes into play when you think about how do you deploy your infrastructure and what does your pattern, your platform pattern actually need to look like. Then again, in the operational space, we have MLOps patterns. This is important for, focusing on the right processes and the automation of those MLOps processes, for example, for model retraining or hyperparameter tuning, or at a higher level, simply the comparison of models. If we then want to single out the infrastructure category of those patterns, then we think of things like serverless, hybrid multi-cloud infrastructure provisioning. Do we have a federated learning context, or simply multiple locations in an edge AI context? So I hope this overview gave you a better understanding of what's necessary to really create AI ML systems at scale. And I'm looking forward to seeing you in the next video. Thank you.